All right, we're going to review quickly for section 12.3, adding and subtracting rational expressions with like denominators. So in the adding and subtracting, it's just like adding and subtracting fractions, where as long as we have a denominator that is exactly the same, we simply add the numerators and you carry along that common denominator. So our example here on page 10, example A, it says we have 5 plus a negative 3 all over that common denominator of y, which means we have 2 over y, and that gives us our final answer. Now our part B here, what we see is a little bit more complicated example. We have a subtraction problem. So remember, when we have subtraction, that means that we have to actually distribute the subtraction. And I'm just going to write down, instead of copying that every time, I'm just going to say this is a LCD, so I don't have to write that denominator every single time. And this is x minus 5 up here, and I'm going to put it in parentheses so that you can actually physically see me distribute this subtraction through. So this is going to become a negative and this is going to become a positive. And then I can say that we have 2 minus x, so 2x minus x, and then plus 5 plus 5. So that becomes a problem where we're adding two polynomials, where we group like terms and combine the numeric coefficients. So we have 2x minus x, which is x, and then 5 plus 5, which is 10, so x plus 10, and that's over my least common denominator, which my LCD is equal to, and I'm going to write it up here so I hadn't forgotten, I really should do that in the first place, a y plus 2. Pardon me. And so that is my final answer. Now, in my next couple of examples here, what we're going to see is some canceling that'll happen. So in this next example, we have our denominator being y minus 2, so I'll copy it down. And then the numerator is 2 minus my y. But those, remember, when we have opposite terms that are the same, we factor out a negative, and that's going to give me a positive y and a negative 2. And now this is over the y minus 2. And so what I see is that will cancel with that, and this simplifies down to a negative 1. It's an important concept to remember about that factoring of a negative 1. That happens several times to us. Now in part D here, we're going to say x squared plus, and then we're going to add in the next one, the 2x, and then plus 1, and then we're going to copy the like denominator, x plus 1, and then we will have x plus 1 quantity squared, because that numerator is a perfect square trinomial. The first and last terms, right? This is a perfect square, this is a perfect square. The root of this one times the root of this one times 2 is the middle term. So we see it's a perfect square trinomial. So one of those factors cancels with one of those. And this one's going to simplify down to x plus 1 alone. And so now we can move on to part E, which we can't see down here. Part E, we have an x minus 1 squared. In that one, we're going to have to expand this out. When I square a binomial, I square the first term. The difference, it's going to be a minus, and twice the product of the two terms, and then plus the last term squared. And then I'm going to be adding in a 2x here, and then I'm going to put this over the common denominator, x plus 1. And then this one and this one add to 0, and so that's going to look like x squared plus 1 all over x plus 1. Now x squared plus 1 is the sum of two perfect squares, which does not factor. We can't cancel the ones, we can't cancel the x squareds. Don't be tempted. So that one is as simple as it's going to get. And that's our review of adding with the like denominators. Now the next thing that we're going to be doing is learning to add when there are unlike denominators. So we're going to have to go back and we're going to have to review finding least common denominators and building higher terms, and then getting to the point where we have the like denominators so that we can even add the numerators and go forward. So that'll be in our next videos.